Welcome back. In the previous lesson, we explored types of tests, experimental designs, and levels of measurement. Based on these, you can figure out which statistical test to use. So today, I'm looking at the specific statistical tests you expected to know for AQA Psychology and how to justify which one is appropriate for a given study. You need to recognize 8 inferential tests for AQA Psychology. Have a look at this list. Each of these tests produces an observed value, which is a test statistic, which is compared to a critical value, which is found in a critical values table, to determine significance. You only need to be able to calculate the sign test. For all the other tests, you will only need to know when to use the test and whether findings were significant based on the information given to you. More on that in lesson 3. So just to briefly recap from the previous lesson, to select the right test, you always ask, which type of test is it? Are we looking for a difference or an association or correlation? What is the design? Is it a related design, so repeated measures or matched pairs or correlation? Or an unrelated design, which would be independent groups? And what is the data? What's the level of measurement, nominal, ordinal, or interval? These 3 factors work together to lead you to the correct test. It's like a decision tree. Here's the all-important table that links each test to its context. You may come across it slightly differently, where at the top you have related design, and then unrelated design. But to not write down the chi-squared test twice, I've done it slightly differently. So pick whichever suits you better. Students often memorize this with a mnemonic. See which one works best for you or make up your own. In the exam, you will be given a scenario and you have to figure out the 3 Ds and then decide which test would be appropriate to use. It can be really helpful to just quickly jot down this table. So if you use a mnemonic like stay cooked with moist sweets to total perfection, just write that down in this way, as you can see here. It won't take you long and it will really help you make the right decision. Now it's time to practice applying that table. Work through each question by identifying whether it's a difference or correlation, the design, so related or unrelated, and the type of data, nominal, ordinal, or interval. Then pick the test that matches all 3. So pause here to work out your answers before I give them to you. So here we have an experiment, which translates to a test of difference. It's a repeated measures design, therefore a related design, and we have ordinal data. So therefore we select the Wilcoxon test. Again, here we have an experiment, so a test of difference. This is an independent groups design, meaning an unrelated design. And the data is nominal. Therefore, we select the chi-squared test. We have another test of difference, an experiment here, which uses an independent groups design, so unrelated, and the data is interval. So we select the unrelated t-test. Here, we're looking for a relationship, which means a test of association or correlation. The design is related because each participant provides a pair of scores. The data is ordinal, hence we select Spearman's row. This study looks for a difference, so it's a test of difference. It uses a repeated measures design, so it's related, and the data is nominal. Therefore, we select the sign test. This one investigates a relationship, so it's a test of association or correlation. It's a related design, pairs of data from the same participants, and the data is interval. Hence, we select Pearson's. Here we have a test of difference again, comparing scores across 2 conditions. It uses a repeated measures design, so that's related, and the data is interval. So we select the related t-test. Finally, we have a test of difference again, an independent groups design, meaning it's unrelated, and the data is ordinal. so we select the Mann-Whitney test. Let's apply the same reasoning to some real-world style research scenarios, similar to how you would see them in the exam. For each one, identify the type of test, the design, and the level of measurement, and then choose the correct statistical test. Pause the lesson here again so that you can figure it out yourself before I give you the answers. Here, the researcher wants to see if there's a relationship between two variables, social media use and happiness, not whether one group is happier than another. So that tells us straight away, this is a correlational study. As for the design, each participant gives us both pieces of information, their own hours on social media and their own happiness rating, so it's a related design. The level of data here is an interesting one, because we have two different types of data. This is where students often get caught out. The number of hours on social media is interval data. It's measured in hours, equal units. The happiness rating is ordinal data. It's a scale, so we know the order but not necessarily equal spacing between points. Here's where a golden rule kicks in. When your two variables are measured at different levels, you always use the lower level of measurement. So, because happiness is ordinal, the overall data level we work with is ordinal. Now that we know that we're dealing with a correlation, with a related design, and with ordinal data, we think of our table and can determine that the correct test is Spearman's rho. Here, the researcher is testing whether something has changed. Anxiety before versus after mindfulness. So it's a test of difference. The same participants are tested twice, before and after, which means it's a repeated measures and therefore related design. Determining the type of data here can be a bit tricky. It may not be immediately obvious. Let's think it through. The number comes from people rating themselves on a scale, maybe 1 to 5, across a bunch of different questions. Those numbers are then added up to give a total score out of 40. So technically, that's built from ordinal responses. We know that a 4 means more than a 3, but we don't know that the distance between them is truly equal. On the other hand, some researchers treat those total scores as interval, because when you add up enough items, the scale starts to behave a bit like a continuous numerical measure. The differences between scores are roughly even, and the total spreads out nicely across a range. Overall, as long as you can justify your decision, you're safe. However, I'd advise you to go with a safer option, the lower level of measurement, that is, the less precise or less informative one. So in this case, ordinal. So, based on these decisions, we would choose the Wilcoxon test. Let's get practical. Here's an example of how AQA might assess this in the exam. Pause again now to work out your answers. Here they're comparing smoking behavior in 2 different years using 2 independent samples. This is a difference between independent groups with nominal data, smokers versus non-smokers. So the correct test is the chi-square test. You would only get 1 mark for naming the correct test. The additional marks you gain for listing your 3 reasons. This question tests your ability to justify the use of a correlational test based on level of measurement. The study measures self-esteem and negative schema, both using questionnaires that produce ordinal data. Therefore, the correct choice of test would be Spearman's rho. So let's recap. To choose a statistical test, always ask the 3 key questions. Are we testing for a difference or correlation? Is it a related or unrelated design? And what's the level of measurement? Once you've answered these questions, you can use the table, ensure you memorize that one, to match the correct test every time. Remember, most errors come from confusing design or data type, so always justify both. I hope this lesson was useful in applying the knowledge you gained in the previous lesson to statistical tests. Thanks for watching. See you in the next lesson.